Okay, so now we're going to talk about the unit quanternion. And as you guys probably know already, a unit quanternion is just this format of two elements where the first part is the scalar part of the element, and then the matrix is generally considered the imaginary part. And you use unit quanternions a lot in predicting rotational matrices and that sort of thing. So I'm going to do a product here for you because the product is actually about the toughest part of the unit quanternion just because it's a special kind of formula. So if you're multiplying these two together, we're going to call this one Q naught, and then Q, and then P naught, and P, just like that. Just so we have kind of labeling system here when I write out this formula. Let's go Q naught, P naught, minus Q transpose times P, then, put a comma in there, and then the second part is Q naught, P, times P, plus P naught times Q plus the cross product of Q and P. Okay, so cranking right on through here. Q naught times P naught is 2 times 1, which is going to equal 2. And then we go to minus Q transpose times P. So we got Q here, 3, 0. I'm going to change that. So that's there. 3, 0, just like that. If you multiply these two matrices together, or these two vectors together, you're going to end up with 1 times 2, which is 2, plus 3 times 0, which is 0, plus 0 times -1, which is 0. And then, of course, 2, this is going to equal 2, so this, and 2 minus 2 is 0, so this is all going to go to 0, just like that. So the first element is 0. Now going on to the second element here. So Q times, this is P vector, sorry. Excuse me, and this is Q vector. Both of these are vectors. Okay, there we go. So this is a scalar times a vector, so you're going to get a vector, and another scalar times a vector, which is also going to be a vector. So Q naught times P is going to be 2 times 2, 0, -1, plus P naught times Q is equal to 1 times 1, 2, 0. Then we're at plus 1, 3, 0, cross multiplied with 3, 0, -1. So this is the cross product right here. Put that in parentheses there. And if you go ahead and crank this puppy out, if you use the cross multiplication rule that we covered a little in one of the other of my videos, JK, you take the vectors and you flip them like this to 0, -1. Oh, sorry, 2 up here, my bad. 2, 0, -1. And you move that down here, you flip it, move it down to the bottom, flip it, move it down to the bottom. And then you just go through here and you do the cross products of these. And you end up with 3 times -1 minus 0, which is going to equal -3. Then you've got -1 minus 0 to -1, but then that's made a negative, so it's going to be 1. Or -1. And then you go on to this, and you go to 1 times 0 minus 6, which is -6. And that will be your vector there. And then this one turns into 4, 0, -2, plus 1, 3, 0, plus, like that. And then this all will end up equaling, if you add these straight across, vector addition, end up with 0, and a magnitude of 4 plus 1 minus 3, which is 2. And 0 plus 3 minus 1, which is plus 1. Sorry, I messed up with this one up here. What it is when you're doing the middle values, you're like this. You do 1 times -1, which will give you -1, and that's minus 2 times 0. But then since it's the second part of what would normally be the determinant, there's negative out of here, so it's more like -1, which turns into a plus. I'm sorry, I messed that up. But so this is a plus. Move it down here. You add them together, and you end up with 4. And then you add -2 and -6, and you get -8. And that is the product of your unit quanternion. Now, so moving on from there, we're going to add another little chunk to unit quanterions. If you want the magnitude of a particular unit quanterion, oops, sorry, my camera. Unit quanterion like this, and you've got Q naught and Q, just like this, and double bars mean the magnitude or the norm or whatever you want to call it. You take the square root of Q naught squared plus Qx squared plus Qy squared plus Qz squared, just like that. And this makes sense because this is the square of each scalar value within this matrix and this scalar value. So 4 right there. So that's a pretty easy way to remember that. Okay, product of 2. Okay, so the conjugate. The conjugate of a unit quanterion, if you've still got this basic unit quanterion up here without the 2 bars, but Q and Q naught, you have Q naught and Q conjugate. Conjugate is a little star there. The way you calculate this is going to be equal to the same forward scalar value, and then just add negative to the vector and multiply a whole vector by -1 or something like that if you're doing the calculation. So the conjugate of a unit quanterion is actually really easy, and you'll use that in some other calculations, such as within the rotational matrices and stuff, and we'll go through a little bit of that later here. So that's unit quanterion.